Hello, everyone. Today we're gonna solve house robber, question 198 on LeetCode. To be honest, I'm just started with dynamic programming. I'm not really familiar with these kind of problems, but I solved it before just to get like an introduction because I also did the step question where it was like a staircase thing, whereas how to get to the third step, second step, first step, and then bottom up. That's the approach. And dynamic programming isn't really hard to understand once you understand the concepts. But hopefully, I get asked a question like this because it's like very intuitive and it's like I can understand the implementation really quickly because it's a very good question. Like realistically, like this is kind of like a realistic question that you could be asked. So you're a professional robber and you're planning to rob houses on a street. So the whole problem is that you cannot rob houses that are adjacent to each other because you can get the police called on you or something like that because you're robbing houses adjacent to each other. But you can rob houses that are not adjacent to each other. So given an array, which is like one, two, three, and one at the end, index zero would be one. So you could rob index three, which would be actually, I mean, you could rob index two, which is three. Also, the whole situation about the arrays is not the amount of houses there is, it's the amount of money the house each house has. So the first house and the third house would have a combined number of $4 because you add them together. But you cannot rob the house adjacent to three, which is one, because that's not the way you're supposed to do it. And you cannot rob two because two is adjacent to one. So that's the whole situation. It's a very intuitive problem. So I guess I'll explain my approach to this problem. Also, this is for progress as well. I might not even do this question properly, even though I already solved it. I'm just trying to like understand it fully because if I've been asked this, I would understand how to approach this. So we wanted to kind of approach this kind of with bottom up. So how I like to think of it is, what if there's no houses to rob? No houses to rob. There are no houses to rob if, literally if, nums, because you're given the rate, equals null, so there's no houses. Oh, sorry. Or nums dot length, yeah, equals zero, then you return zero because it's an int class. So what about the first house? First house. So I think this is kind of self-explanatory. If nums, what's it called? Nums of nums dot length equals one. We want to actually just return nums at zero. Yeah, that should be, you know, makes sense. That's the first house you want to wrap. Second house. So a second house kind of like is more um has more code to it. So it's just you get the max number between the first one and the second house. So if nums length equals 2, we get the return math max between the between nums at 0 and nums at 1. That's perfect. So it can't be too bad because these are just the like beginning scenarios, bottom up. But we kind of are gonna get to the meat of the solution, which is kind of where you find something that's adjacent. So we want to create an array to actually find what's adjacent. So int what's let's just name, sorry, um dp, because that's what everyone names it. Okay? A new int nums only. So also I learned that you have to like do dp of 0 equals nums at 0 because we actually initiated the the adjacent stuff. So then dp at 1. Actually, is dp at 0? dp at 0 equals numbers. dp, okay, hold on. dp at 1. dp at 1. Actually, you know what's fine. Equals nums at, what's it called? 1. dp. I don't think we have a dp. I don't think we have that index yet. So here we're just gonna want to create int equals. So we're starting at 2. We're starting at 2. As you can see, we're starting at 2 because we start at 2 because the house is already at the second house. So we start at 2, that second iteration, and then I is less than nums.length. And then I plus plus. So here is kind of like finding the actual adjacent parts. Let me adjacent. So dp at I, since we are actually trying to solve for it, equals. So we want to find the max value between nums at I, and then plus the values that aren't adjacent. So the next one. So if you have a, for example, 1, 2, and 3, it gets 1, 3. So plus nums I minus 2, I minus 2. That should be fine, and this one should be nums. No, sorry. dp minus 1. dp, because we're getting this here instead of nums, because nums would just be, it wouldn't be adjacent. And then dp just a regular. So it's, if this is adjacent, and then yeah, that should be this, the solution, and we just want to return dp nums length minus 1. That should be the solution. It's not a bad problem. It's generally not a bad problem. Yeah. Honestly, once you get these scenarios down, this is also self-explanatory because you get the indexes. As I think I explained it well. Get the indexes of this, and they would equal nums, and then you just start again from here. I think it's not a bad problem. Thank you.